All right, new engineers want to know how those massive websites handle like millions of users doing all sorts of things.
Things like buying, posting, or even, those self-driving cars, how they navigate all that crazy traffic.
Yeah, exactly. We're talking event processing systems.
Crucial in today's tech world, let me tell you.
We're actually using this cool article by Anudeep Balla, designing a scalable and resilient event processing system.
He talks about some pretty wild stuff.
Like what?
Well, things like using machine learning to predict, like when you need to scale up your system.
Whoa, hold on. So we're talking about preventing those website crashes during like a Black Friday sale.
Exactly, before things get totally out of hand.
Sign me up. But before we get ahead of ourselves, like, what are these systems all about at their core?
It all boils down to managing this constant flow of events, purchases, sensor readings, social media updates, you name it.
Okay, so like a ton of stuff happening all the time.
Tons. Think of it like a highway. If you have too many cars, or events in this case, trying to cram in at once, what happens?
Good luck. Total traffic jam.
Right, and everything slows to a crawl, your website crashes, your app freezes, nobody's happy.
So how do we prevent our data highway from turning into a parking lot? Asking for a friend.
Well, Balla's article, he calls out rate limiting as like one of the key strategies here.
Rate limiting, what's that?
Basically, it's like putting traffic lights on our highway.
Right.
You're controlling how many events can enter the system every second.
So like a bouncer at a popular club. Making sure things don't get too crazy.
Precisely. Gotta manage the flow.
Okay, that makes sense. What else?
Another technique is batch processing.
Batch processing. What's that now?
Instead of letting all the cars, all the events zoom in individually, you group them up into convoys.
Ah, so we're streamlining things. Gotcha. Any other ways to, fine-tune this whole event flow management thing?
Oh, there are some more advanced techniques out there, like Balla mentions backpressure mechanisms.
Backpressure mechanisms.
Yeah. It's basically where your system, it actually tells the event producers to slow down, if things are getting too hectic.
Wait, so if our payment system is about to, like, explode from too many people buying stuff, it can, like, signal the website to chill out on taking new orders.
Exactly. It's like a feedback loop to prevent a total meltdown.
It's pretty slick. Anything else?
Oh, and don't forget about prioritizing. Not all events are created equal.
Right, some are more important than others.
Yeah, so you can tag events, categorize them based on importance.
Okay, so those high-priority events, like, they get processed faster.
Exactly. Think of it like an emergency room.
The most urgent cases get seen first.
You got it.
Okay, we've got our events flowing smoothly, but, like, what about where all this data is actually stored?
The data store.
So we need to, like, keep an eye on that too?
Absolutely. Just like you just hit the gas in your car and forget about the engine, right?
Right, you gotta be sure the engine's running smoothly.
Exactly. We got to make sure our data store, that engine, is running smoothly.
Makes sense. But how do we know if our data engine is about to, like, throw a rod?
Metrics.
Metrics.
Metrics are our best friend. It's like checking the oil pressure, engine temperature,
So we're monitoring all those vital signs.
Exactly. And there are tools out there like Prometheus or Grafana.
Okay.
They can track all sorts of vital signs, query latency, disk I/O, CPU utilization, all that good stuff. They give us a real-time view of what's going on.
Love that. Like a dashboard for our data engine.
You got it.
But what happens if, something does go wrong? Do we just sit there and watch the gauges go haywire?
Nah, we set up automated alerts.
Oh, okay. So like an alarm system for our data store.
You got it. If any of those metrics go out of bounds, boom, we get notified.
Okay. Through what?
Tools like PagerDuty or even Slack, whatever works for your team.
So we're constantly monitoring, getting alerts if something looks fishy.
247 vigilance.
But how do we prevent those issues in the first place?
Well, that's where those regular health checks come in.
Health checks?
Yep. It's like taking your data store in for a checkup, making sure everything is running as it should be.
And if it's not?
If not, these health checks can actually trigger a failover to like a backup system. Imagine it like having a spare tire in case of a flat.
Okay, so we're monitoring, alerting, doing those regular checkups. Anything else we need to do to keep our data engine humming along?
Don't forget about capacity planning. Got to make sure your data store can handle those rush hour traffic times,
Rush hour.
Yeah, those peak loads when events are just coming in hot and heavy.
So we're making sure we have a powerful enough engine
Right.
to handle all that data horsepower.
Right. It's absolutely essential if you're designing for scale.
Love that analogy.
Yeah.
Okay, so we've got a good handle on, like, managing the event flow and making sure our data store is in tip-top shape.
Solid foundation.
But what happens when, like, the amount of traffic on our data highway starts to, like, fluctuate? Like,
Yeah.
sometimes it's busy, sometimes it's not.
Well, that brings us to another, like, really fascinating aspect of event processing systems, dynamic processing adjustment.
Dynamic processing adjustment. Lay it on me.
Think of it like a car that can change its engine size based on the road conditions.
Okay, I'm picturing a futuristic transformer car, switching between a tiny engine for city driving and a massive one for the Autobahn. How does that translate to, like, event processing?
Well, one technique is adaptive load balancing. The system can smartly distribute work across multiple nodes based on the current traffic.
Nodes.
Yeah, think servers, like a smart GPS system, rerouting cars to avoid traffic jams.
Oh, okay, so we're dynamically redirecting those events to avoid bottlenecks. That's pretty cool. Any other ways to adjust our processing power on the fly?
Absolutely. We can use dynamic thread pool management, adjusting the number of threads based on the system load.
Oh, that's...
Those are like the workers processing the events.
Got it. More events, more workers.
Exactly. Fewer events, we scale back. Libraries like Java's fork join pool make this like super easy to implement.
Okay, so it's like having a flexible workforce that can adapt to changing demands. Pretty cool. Any other tricks up our sleeve?
Of course. There's elastic scaling where we can leverage like those cloud platforms.
Cloud platforms.
Think AWS Lambda. We can automatically scale our processing power up or down, based on the incoming traffic. Super efficient.
Okay, I'm definitely getting the picture here. We need to be able to, like, adjust our processing power on the fly to handle whatever comes our way.
Adaptability is key.
But, like, what happens if things really go haywire? Like, system meltdown, code red, what do we do?
That's where we have the circuit breakers.
Circuit breakers.
Yeah, think of them like emergency brakes on a runaway train. They temporarily halt processing if like a downstream system is overloaded, saves you from a complete system meltdown.
Whew, that's a lifesaver. Okay, we've covered a ton of ground already. We've talked about managing that event flow, keeping our data store healthy, even dynamically adjusting our processing power, and I feel like we're just getting started.
We've only just scratched the surface. There's a whole world of industry practices and even like futuristic approaches to explore.
I'm already hooked. Let's take a quick breather, and then we'll dive into those industry favorites. Stay tuned, new engineers. We're about to unlock the secrets of building rock-solid event processing systems.
Welcome back. So now that we've got like the basics down, let's look at what the pros are using out there in the real world.
All right, time for the industry standard tools. Hit me.
One name you'll hear all the time in event processing, Apache Kafka.
Kafka. Yeah, I've definitely seen that name pop up, but, like, what's the big deal? Why is everyone talking about it?
Well, Kafka is this super efficient messaging system, right? It's like the central hub, gathering events from all over and then distributing them to different processors.
Okay, so it's like keeping all of our events, organized, making sure they get to where they need to go. But how does it handle, like, massive amounts of data without, choking?
That's where Kafka's consumer groups come in.
Consumer groups.
Basically, we can group our event processors together so they can share the load. And then, with this thing called offset tracking, we can be sure that, like, no event gets lost in the process.
So Kafka's got our back, keeping everything in order, making sure nothing falls through the cracks. What other tools or, like, practices should we know about?
Well, there are some really clever architectural patterns out there, like CQRS, stands for Command Query Responsibility Segregation.
CQRS. That sounds intense. Can you break that down for me a little bit?
It's actually a pretty elegant idea. You separate the read and write operations for your data.
Okay, so, like, instead of just using a single database for everything, we're splitting things up.
Exactly. So you might have like a write optimized store for ingesting all those events, maybe something like DynamoDB, and then a separate read optimized store, for your queries, something like Elasticsearch.
Ah, so we're using the right tool for the job.
Mm-hmm.
Divide and conquer, right?
You got it.
Any other patterns that, like, work well with this CQRS thing?
Yeah, event sourcing often goes hand in hand with CQRS.
Event sourcing.
So with event sourcing, every change to your application state, you actually store that as an event. Creates this like chronological log of everything that's happened.
So instead of just storing the current state, we're keeping a full history of how we got there.
Exactly. And this event log, that becomes like your single source of truth, You can actually rebuild the entire current state of your application just by replaying all those events.
Well, it's like a time machine for our data. We can go back and see how things looked at, like, any point in time.
Yeah, pretty cool, right? And there are tools out there that make this a lot easier, like Event Store.
Okay, so we've got Kafka for managing the flow,
Hmm.
CQRS, and event sourcing for like keeping things organized. Anything else we should be thinking about?
One final but crucial practice, chaos engineering.
Chaos engineering. Okay, that doesn't sound very, orderly. What is that?
It may seem kind of counterintuitive, but it's about intentionally introducing failures into your system.
Wait, hold on. We're deliberately causing problems. Isn't that kind of risky?
Well, think of it like a stress test, right? By pushing your system to its limits, but in a safe environment, you can actually uncover weaknesses and make your system more resilient in the long run. There are tools that can help with this, like Gremlin or Chaos Monkey.
So it's like a martial arts training session for
Yeah.
our system, preparing you to take a punch. Okay, I'm starting to see the value in a little bit of chaos. So we've got a solid grasp on the industry standard practices now. Is there anything like beyond the conventional? Any, out of the box ideas?
Of course, event processing is always evolving. We're seeing some really innovative, almost futuristic approaches emerging.
Ooh, futuristic. You've got my attention. What's on the horizon?
One area that's super exciting is using machine learning for predictive scaling.
Predictive scaling.
Imagine being able to anticipate, those traffic surges before they even happen based on historical data, trends, all that.
It's like having a crystal ball that tells us when to expect a rush of events so we can, be ready.
Precisely. By training those machine learning models on past data, you can identify those patterns and then proactively adjust your resources.
Predictive scaling. That sounds incredible. What else is brewing out there on the cutting edge?
Another interesting concept is event deduplication.
Event deduplication.
It's all about filtering out those redundant events that can, like, bog down your system.
So it's like a spam filter for our events, only letting through the important ones.
Exactly. Using things like hashing techniques or unique identifiers, can make the system way more efficient, prevent unnecessary processing.
Okay, what else?
There's also this thing called edge computing. That's where we move some of that processing power closer to the source of the events.
Well, sort of the source.
Yeah, like imagine having these mini processing centers strategically placed near the action. Tools like AWS IoT Greengrass or Azure IoT Edge, they can help with this.
So we're basically pre-processing those events right at the edge of the network.
Exactly. Reduce the load on our central system.
Smart.
Yeah.
Okay, give me one more futuristic idea to wrap things up.
How about polyglot persistence?
Polyglot persistence. All right, I'm intrigued. What is that?
It's the idea of using different types of databases for different tasks, right?
Yeah.
Choosing the best tool for the job. For example, you might use a time series database, something like InfluxDB, for storing all those metrics, and then a relational database for like your transactional data.
Okay, so instead of a one-size-fits-all database, we're using a mix and match approach to, optimize our system.
You got it. Polyglot persistence. It lets us fine-tune that system for, peak performance and efficiency.
Which has been like a key theme this entire deep dive.
Yeah.
All right, new engineers, we've journeyed from managing event flow, monitoring our data store, dynamically adjusting our processing power. We explored industry practices and even peeked into the future of event processing.
It's been quite a journey, but this is just the beginning.
I know, right? There's so much more to learn. But before we wrap things up, let's take a moment to, recap. What are the big takeaways for our new engineers listening out there? Okay, so new engineers, think back to everything we've talked about. Managing that event flow, keeping our data store healthy, making sure our processing power can scale up or down as needed.
And all the cool tools and techniques, from the industry standards to those futuristic approaches.
So much to think about. What are the big takeaways?
I think, the key takeaway is it's all about having like a toolbox, right? A toolbox full of strategies.
A toolbox. I like that.
And knowing when to use the right tool for the job, whether it's basic rate limiting or that really cool predictive scaling with machine learning.
Right, we talked about a lot. But they all play a role in keeping those systems running smoothly, no matter how much data comes flying in.
Exactly. It's all about keeping that data highway flowing, right?
We can't let it turn into a parking lot. But, it's not just about knowing all the fancy techniques. We've got to be adaptable, too.
Right. Always monitoring our system's health and being ready to scale things up or down, at a moment's notice. Flexibility is key.
And don't be afraid to get creative.
Absolutely. Try those unconventional approaches. The world of event processing is always changing. Who knows, you might come up with the next big breakthrough.
That's what makes this field so exciting. pushing the limits, finding those innovative solutions, and just keeping those systems humming along.
I think this deep dive was just the tip of the iceberg. There are tons of resources out there, open source tools like Apache Kafka,
Right, we mentioned that one.
yeah, and cloud-based platforms like AWS Kinesis and Azure Event Hubs. It's a playground for anyone who loves to tinker and build.
So many possibilities. Any final words of wisdom for those new engineers out there as they start to explore this crazy world?
Embrace the challenge, stay curious, never stop learning, and, don't be afraid to ask for help.
Yeah, collaborate with others, learn from their experiences. That's how we all grow and build better systems, right?
Absolutely. And who knows, maybe someday you'll be the expert guiding those new engineers through this whole thing.
I love that. Well, that's a wrap on another deep dive. We explored the world of event processing systems.
From the ground up, those core concepts to those mind-blowing, future possibilities.
It was awesome having you with us.
Thanks for having me.
And to all you new engineers out there, before you go, think about this. Imagine you could design an event processing system for your dream project.
Ooh, dream project.
What kind of unique features would you include? Let your imaginations run wild. The possibilities are endless. Until next time, keep exploring, keep learning, and keep pushing those boundaries.